To review linear functions, let's start with the equation. The equation is y equals mx plus b, where m is your slope and b is your y-intercept. Now your slope is the rise over the run, especially if you're looking at a graph. This tells you your steepness of the line. You could also calculate it as the change in the y over the change in the x values. That's easy if you have a table or if you have a set of coordinate points. If your slope is positive, it's going to increase upwards from left to right. If it's negative, it's going to go down from left to right. If it's 0, it's going to be flat. And if it's undefined, it's going to be straight up and down. Now your y-intercept is the point where it crosses the y-axis. So it's usually written like this, 0, b, where b is the y-intercept. You would have a value there. On a graph, it would be a point that's sitting on the y-axis. Let's say your line went through that way. So looking at an example of an equation, y equals 2x, let's say minus 3. Which one is the slope and which one is the y-intercept? The constant, the one without the variable, that's your y-intercept, that's your b. The number that's the coefficient of x is your slope. So that is your m, or you could just write slope. Try this one. What is the slope and the y-intercept of this equation? Okay, so if you picked negative 4x as your slope, you are correct. That's the number that's in front of x. That's the coefficient of x. And this positive 5 here is your y-intercept. Okay, let's start looking at some tables now. Let's say we have the table x, y, and let's start with negative 1, 0, 1, and 2. And then on this side we could do 3, 5, 7, 9. So if you're trying to write an equation from a table, you want to find your important values, meaning you want to find your slope m and your y-intercept b. So your slope is your change in y over your change in x. So you want to look at the y values and see how they're changing. Well, this one's easy because 3, 5, 7, 9, they are all changing by plus 2. That's called a constant rate of change. All linear functions have a constant rate of change in a table. So my change in y is a 2, plus 2, positive 2. My change in x, these are all increasing by plus 1, so a 1. So you could say 2 over 1, or you could just say 2. They're equivalent. It means the same thing. Then your y-intercept is a value of y when x equals 0. Well, here's a value of y when x equals 0. That means my y-intercept is 5. The value of y when x is 0. So now I just plug this into my equation. Y equals 2x. It's a positive 5, so plus 5. That would be my answer for that one. Now sometimes they don't give you the y-intercept in the table, so let's look at this example. Let's say we have 2, 5, 3, 7, and 4, 9. Okay, in this one, we do the same routine. You want to find the slope first, so m equals 5, 7, 9 is plus 2. 2, 3, 4 on the x is plus 1. So my slope, again, in this example, is also 2. But I don't have a y-intercept in my table up here. I don't have where x is 0. So in this example, sometimes you could work backwards. Since x is increasing by 1, you could work backwards. From here to here is plus 1, and here to here is plus 1. So to work backwards, I would do the opposite, which is minus 1. So 2 minus 1 is 1. And then this side is plus 2, so to work backwards, I minus 2. So 5 minus 2 is 3. I still don't have my y-intercept, so we can work backwards again. So 1 minus 1 is 0. That's what I'm looking for, where x is 0. And 3 minus 2 is 1. So this ends up being my y-intercept right here, most importantly the 1. So b equals 1. And now I could write my equation. Y equals 2x plus 1. Okay, let's do some harder examples. Let's do some where we don't have a table. So let's say we're given 2 points and we have to write an equation of a line. This gets a little bit harder. So if we have 2 points, let's say we have the points 1, -1, and we have 3, -7. We still have to find the slope and y-intercept. So we still have to find what m equals. We still have to find what b equals, and then we can write our equation. So the easiest thing to find first is the slope. Remember, the slope is the change in y over change in x. Well, we just got done doing tables, so why don't we take these 2 points and put them in a table. 1, -1, 3, -7. And let's find your change of y first. -1 to -7 is -6. 1 to 3 is +2. So our slope here would be -6 over 2, and we can reduce this. A negative divided by a positive is a negative, and 6 divided by 2 is 3. So -3 is my slope. Now again, I have to find my y-intercept. So you could use the equation to find your y-intercept, and this is more Algebra 1 based. You'll do this a lot in 9th grade. So to do this, you would do y equals mx plus b. That's our formula. And then we're going to plug in things that we know. So we know the slope. So far I have y equals, instead of m, I'm going to plug in my slope here. So y equals -3x plus b. And remember before we said that the y and the x are placeholders? Well, they're placeholders for any x and y coordinate over here. So let's pick 1, -1, because they're a little easier to work with than 3, -7. This is my y coordinate. This is my x coordinate. So instead of y, I'm going to plug in -1 equals -3. And then instead of x, I'm going to plug in this x coordinate of +1. And then I have plus b. And now we simplify. So now we have -1 equals, this is multiplication, so -3 times 1 is -3 plus b. Now to solve this, we do inverse operation. So I want to get b by itself. That's a -3, so I'm going to add 3. Whatever you do to one side, you do to the other. And then I get 2 equals, this cancels, b. So we found our y-intercept. So we have a slope of -3, a y-intercept of 2. My final answer for my equation is y equals -3x plus, whoops, not plus b, plus 2. Okay, why don't you try one on your own? Let's do another example. Let's say you are given, let's say 5, 3, and 4, 5. So pause the video and try this one. Okay, the first thing we want to do is find our slope. So let's make a table again. Now there's many different ways you could find your slope besides making a table. You could use the slope formula. You could keep with the table. You could subtract the coordinates. You could technically graph them if you wanted to graph them, but I feel like the easiest thing for you to do is make a table. Now it doesn't matter the order in which you put the points in. You could put them in order from their x coordinates, meaning 4 is smaller than 5, so you could put 4, 5 first. But let's say you put 5, 3 first because you did it in the order that it came. It's fine. It'll work out the same no matter which way you put them in. So 3 to 5 is plus 2, and 5 to 4 is minus 1. So for the slope m, remember it's the change in y over change in x. My x values are changing by plus 2. My y values are changing by minus 1. And then you could simplify this. 2 divided by -1 is -2. So that's my slope. Let's find the y-intercept. So again, use the equation because it's a little bit easier. Y equals mx plus b. Instead of m, we could plug in this -2. And then instead of y and x, we could pick an x coordinate. It doesn't matter which one you pick. Let's say we pick 5, 3, and we're going to plug in all of this information. So instead of y, I'm going to use this y coordinate of 3. So I'm going to have 3 equals. Instead of x, I'm going to use this x coordinate here of 5. So I'm going to have negative 2 times 5 plus b. So the negative 2 is your slope m, and x is 5 for the x coordinate, and y is 3 for the y coordinate. So now we're going to solve this. So 3 equals negative 2 times 5 plus b. So we're going to simplify negative 2 times 5, which is negative 10, plus b, and then do inverse operation. So that's a minus 10. We're going to add 10. Whatever you do to one side, you do to the other. And we're going to get 13 equals b. So here's our slope. Here's our y-intercept. Our final answer is going to be y equals negative 2x plus 13. Here's another challenge for you. Let's say you're given only the slope and a point. So let's say you're given the point 5, 0 and the slope of negative 2. Now looking at this point, this is not the y-intercept, because remember the y-intercept for b is 0 comma whatever that y coordinate is. This is not the y-intercept, so don't get that confused. So with that said, let's solve this. So let's write the equation first. Y equals mx plus b. And let's plug in all the information we know. So what do we know? We know that the slope is negative 2. So that's going to go in for m. We don't know the y-intercept, but we have this point. Remember, a coordinate point is x comma y. So we could plug in everything that we know, and then we could solve for the y-intercept. So instead of y, I'm going to plug in this y coordinate here of 0. So I'm going to get 0 equals, instead of m, I'm going to plug in negative 2. Instead of x, I'm going to plug in 5. And then I don't have what the y-intercept is, so that's going to stay as b. And then we're going to simplify. Negative 2 times 5, 0 equals negative 10 plus b. And then inverse operations, I see a minus 10, so I'm going to add 10. I'm going to add 10. And I'm going to get 10 equals b. And that's the piece of information that we were looking for. So I have the slope here. I have the y-intercept here. My final answer is y equals negative 2x plus 10. And it's a plus 10 because this 10 is positive. If that was a minus 10 or a negative 10, then I would have put a minus sign here. The last thing we're going to talk about with linear functions is graphing a linear function. Let's say we have this equation, y equals 2x minus 1, where the minus 1 is our y-intercept, and this 2 is our slope. So let's first plot the y-intercept. That's your first step when you're graphing a line. So let's say all of these values here, they go up by 1. So here's 1, 2, and 3 of the x. Here's negative 1, negative 2, negative 1, negative 2, negative 3, positive 1, positive 2, positive 3, positive 4. Okay, so let's graph this. So the y-intercept is negative 1, so you want to find negative 1 on the y-axis. This is your y-axis. So wherever you see negative 1, which is about right here, you're going to plot a point. Then your slope is 2. Remember that your slope before we said was rise over run. If it's positive, you rise up and then run to the right. Remember, you always, always, always run to the right. So we're going to start at the y-intercept, and you're going to go up to right 1. Rise 1, 2, run 1. There's your next point. Then we're going to do it again. So rise 1, 2, run 1. Now I filled in my points on the top of the graph. Now let's try to get some points down in this area of the graph. We're going to do the same thing we did. If we could rise up 1, 2, and over 1, then we could rise down 1, 2, and over 1 this way. Okay, and then you could draw a line through your graph. Mine's not going to be very straight, but you could draw a line through your graph, and that is the graph of this equation here. Let's try one more. Okay, let's say we were going to graph y equals -1/2 plus 2. Okay, so -1/2 plus 2. So our y-intercept here is this positive 2. So you want to find positive 2 on the y-axis. So if this is 1, this right here is going to be positive 2. Now a slope of -1/2. If it's negative, instead of rising up, we want to rise down 1. And again, you always run to the right. So we're going to go down 1 to the right 2. So down 1 to the right 1, 2. So that's about here. We could do it again. Down 1 to the right 1, 2. That's over there. So if we could go down 1 and right 2, we could also go up 1 and left 1, 2. And then that is your line of this equation. Y equals -1/2 plus 2.